Multiple choice questions. First question. V bar VRMS bar speed, you know the mean speed, root mean square speed, and most of the speed. Okay, जो भी है ठीक है, absolute temperature. So the mass of molecule is m, then number no molecule can have speed greater than square root of 2 times V RMS. No. Infinity से जाता है distribution. You can't just say that. No molecule can have speed less than Vp upon. नहीं यार, zero speed वाले भी molecules रहते हैं. What's the okay? Vp is less than V bar is less than VRMS. Yeah, that's right. The average kinetic energy of the molecule of a molecule is 3/4 Vmp squared. So it's 3 upon 2 VRMS plus MVRMS squared, right? So like 3 upon 2, but then VRMS is just a square root of 3RT upon M, right? Or like, okay, or क्या V most probable is equal to square root of 2RT upon M. So Vp squared, that is equal to 2/3 of, is that right or not? Yeah, okay, so God, something's not right with this thing. It's supposed to be half mv squared, right? Half m vrms squared, which is like 3t upon m and all that stuff. So basically, like, yeah, 3 upon 2, right, 3 upon 2 m, and then right, 3 rt upon m, right? Okay, so like ऐसा हो जाएगा ये. That makes sense. So it's actually correct. So D is correct. Yeah. So D is the correct thing and C is also correct. Next question, second. Second is a hot body emits radiation which has maximum intensity at frequency Vm. If the temperature of the body is doubled, so frequency Vmb, right? We know that lambda max times temperature, that is equal to the Weinstein displacement constant. So right, it's like C upon, क्योंकि yeah, electromagnetic waves है, so C upon frequency of maximum energy, right? So maximum intensity at some frequency, that frequency is, of course, that's equal to the Weinstein constant. Like, okay, T is proportional to the max intensity frequency, right? So अपन ने क्या टेम्परेचर को डबल कर दिया, देन ये भी डबल हो जाएगा. सो इसको तुम एफ नहीं, तुम इसको ऐसे म्यू जैसे लिख रहे हो, तो वॉट एवर. सो ये भी चीज भी डबल हो जाएगी. Maximum intensity radiation will be of frequency 2 Vm, of course. So A is the answer. Total energy emitted per second will increase by a factor of 16. Sigma T power 4 होता है. So yes, C is right. Total energy per, okay. No, not a factor of 4. This is wrong. Okay. So D is wrong. Next. Molar heat capacity of a diatomic gas can be, R is universal gas constant. You want the molar heat capacity of a diatomic gas. Okay, it can be, right, it could be anything, you know. It can be 0, of course. तुम change करो temperature but हमारी heat 0 है, adiabatic processes, right? It can also be 5.2 R because जब constant volume रहेगा, then that's happening. And constant pressure, this thing is happening. It can also be infinite. तुम जितना भी heat इसमें put करो, तुम्हारा temperature change नहीं हो रहा है. So an isothermal process basically, right? All of these guys. So yeah, A, B, C, D. It's an ideal gas, right? Ideal gas. So A, B, C, D. Next question, fourth. Fourth is the specific heats of gases are Cp is equal to 0.2. Okay, जो भी है. And Cv is given. ठीक है, स्पेसिफिक हीट्स दी है अपने को, टेक आर इज इक्वल टू, ठीक है ना, कर लेंगे. क्या करना है अपने को, मोलर मास ऑफ द गैस ढूंढना है अपने को. स्पेसिफिक हीट्स दी है एंड यू हैव टू, गामा कितना है, 0.2 अपॉन 0.20 अपॉन 15 which is 4 upon 3, right? Isn't that right? Of course that's right. So that's basically like नीचे 6 आ जाएगा, ऊपर 8 यानी कि 6 plus 2. So you can see कि degrees of freedom 6 होने चाहिए. So Cv is just basically 3, right? Cv is 3, Cp is 4, whatever. अपने करना क्या है ऐसे, the molar mass of the gas is, wait, okay, 0.2 and that's like 0.15. Wait, something's wrong because Cv plus R is supposed to be 0. Oh, it's like per mole. Okay, this is different. ठीक है ना. So Cp minus Cv is equal to R. Yeah, so इसमें per mole है and this is per gram. So ओके आई गेट इट, आई गेट क्या हो रहा है. स्पेसिफिक हीट्स मतलब मोलर स्पेसिफिक हीट्स नहीं है, इट्स स्लाइटली डिफरेंट. ठीक है ना, यू कैन फिगर आउट द मोलर मास. नंबर ऑफ डिग्रीज ऑफ फ्रीडम इज 6. हाँ ठीक है, तो अपन सी तो बोल ही सकते हैं. इट्स नॉट 8, इट इज 6. ओके. And what is this thing? It's like 0.05 calorie per gram, right? Okay, that is equal to Celsius वगैरह वो ठीक है. That's equal to, oh and by the way per gram है, right? What we want is per mole. So okay, और R कितना है? This is equal to R whatever. R is 2 calorie per mole. So 2 calorie and 1 mole is whatever the molar mass is that times of gram. Makes sense, right? Equivalently वो इतना रहेगा. So yeah, like 2 upon whatever the molar mass is, that's equal to 0.05. So the molar mass is 2 upon 0.05, which is क्या है? 0. Sorry, 2 upon 0.05 is 200 upon 5, which is 40. Yes, so 40 is the molar mass, 40 grams. A is correct and C is correct. Next question. Fifth क्या है? According to kinetic theory of gases, which of the following statements will be true? Ideal gas cannot be liquefied. Yeah, उसका B critical action में रहता ही नहीं कुछ. So हाँ, I guess so, right? Yeah, you can actually not do that because वो defined नहीं है properly. So हाँ. The molecules of ideal gas do not obey Newton's law of motion. I think A correct है. Okay. The molecules of ideal gas do not obey Newton's law of motion. They do obey the law of motion. What? Okay, pressure of gas is always inversely proportional to its volume. Depends कौन सी process तुम use कर रहे हो. So हाँ, okay, whatever. Molecules of gas never move in a straight line. Well, they do move in a straight line all the time. Except if gravity है, but चंद दो gravity का ना सोचो मत. Okay, ये डिपेंड करता है यार, तुमने कहाँ पे रखा है वो कंटेनर को. तुम इसको मतलब स्पेस में छोड़ के आया, तुमने ग्रेविटी में रखा हुआ है, क्या हो रहा है? इफ इट्स इन ग्रेविटी सिचुएशन तो फिर यहाँ पे स्ट्रेट लाइन में नहीं मूव कर सकती बिकॉज इट विल बी पुल्ड डाउन. अगर वो स्पेस में है देन इट विल मूव इन स्ट्रेट लाइन. तो क्या डी इज ओपन, इट्स ठीक है. और सी भी थोड़ा सा डिपेंड तुम कौन सी प्रोसेस यूज कर रहे हो इसमें. सो विच द फॉलोइंग स्टेटमेंट विल बी ट्रू? आई थिंक ए और बी तो अपन, बी तो पूरा से गलत है. सो ए इज करेक्ट फॉर श्योर. Ideal gas cannot be liquefied. B, the molecules of ideal gas do not obey laws of motion. Yeah, well, actually they do obey laws of motion. So B is incorrect. Pressure of gas is always inverse proportional to its volume. Depends. Molecules of gas never move. Depends. Sixth. In the given thermodynamic process, the correct statement is, I think D बोल दो यार, because yeah, सोचो मत ग्रेविटी के बारे में, just बोल दो. Because oh sorry, D is actually incorrect, right? हाँ, फिर तो अपन D को necessarily exclude कर ही सकते हैं. So either it's A and C or it's just A. जो भी है. Sixth is in the given thermodynamic process, the correct statement is okay, so it's like A. Heat given in the complete cycle A, B, C, A. Right, that's 0 and whatever. Work done in the complete cycle is 0. No. Work in the complete cycle A, B, C, A. So इसमें volume increase हो रही है पहले, right? This is the positive, then this is like इसमें इतना negative work. हाँ ठीक है ना, तो इसका area जो that's the work done by the gas. Makes sense? Which is कितना half, कितना इसकी height कितनी है? P naught. इसमें width कितनी है? P naught. So P naught upon 2, of course. C is actually correct. Heat given in the complete cycle is 0. No, it's just negative of this thing. Right, so अपने correct statement चाहिए, just C. Next question. 7th. Right, okay, next. क्या है? For an ideal gas, the change in internal energy is a constant. In a constant pressure process. Sorry, change in internal energy in a constant pressure process from temperature T1 to T2 is equal to NCV times T2 minus T1. Yeah, I agree. Okay, and where C is the molar specific heat at constant volume and N is number of moles. So yeah, A is true. Okay, the change in internal energy of gas and work done by the gas are equal in an adiabatic process. What? Change in internal energy of the gas? What? Wait, sorry. change in frequency of the gas and work done by gas are equal in, of course, right? So wait, you mean by gas? No, 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 no. That's not right. It's work done on gas. Those two are equal. Uh, come on, magnitude wise वो equal हो गया, I get it, but it's not right. मे बी बी करेक्ट है, मे बी नहीं है यार। इस टाइप के क्वेश्चंस क्यों डालते हैं लोग? अब मैं इसको ऐसे कैसे इंटरप्रेट करूँ? साइन इसमें लूट ही नहीं, बिकॉज साइन डज मैटर, राइट? ठीक है जान दो, बी कर ही देते बिकॉज मोस्ट लाइकली या वैसे ही लूज क्वेश्चन है। द इंटरनल एनर्जी डज नॉट चेंज इन एन आइसोथर्मल प्रोसेस, मेक सेंस, श्योर। आइडियल गैस के लिए या ऑल द ऑप्शंस आर करेक्ट, सो डी आई थिंक सो। और या एट नेक्स्ट, an ideal gas is taken from point A to C on PV diagram through two processes OAC and AVC. So OAC is what? Okay, A to C जा रहा है ना, ठीक है। This OAC is isothermal, but shouldn't be like A. Okay, sorry, AOC, of course, right? AOC is isothermal and और दूसरी प्रोसेस क्या है? And ABC, तो तुमने ऐसा किया, fine. Process AOC requires more heat than process ABC. AOC में work done by the gas is definitely more because ये area रहेगा, and yeah, that is more, और delta T 0 नहीं है, delta T same है। It means is what is isothermal, so AC का temperature same, okay, then delta T 0, right? So internal energy change 0, so heat is just equal to that, right? So the heat input is just equal to work done by the gas, so yeah, it's actually the same thing, right? So it is actually bigger than this heat in, of course. Yeah, so A is correct. इसमें works are well. ABC require more heat, नहीं, both processes A, okay, same amount of heat at S, ठीक है, next. Ninth is two vessels of same volume contain same gas at same temperature, pressure in vessels P ratio 1:2, ठीक है, same volume, same temperature, same moles है, नहीं, सिर्फ volume temperature same है, pressures in vessels be 1:2, so moles will be 1:2 as well. Ratio of average kinetic energies is 1:1, right? Average क्योंकि molecule के लिए चलाएगी, yeah, of course. Wait, total kinetic energy का average तो नहीं करो तुम, whatever. Okay, ratio of the root mean square velocity is 1:1. Depends, masses तुम्हारे कैसे है, वो सब कुछ depend करता है। Ratio of average velocity is 1:2. Okay, this is getting weird. Total velocity, we don't know what that is. Wait, okay, it's the same gas, so okay, molecular mass same, then yeah, the ratio of root mean square velocity is in fact 1:1, so B is right. And ratio of average kinetic energy, do you mean the total kinetic energy का average की actual में for every atom जो I don't know, ratio of average velocity is okay, no, it's actually the same stuff. Ratio of number of molecules is 1:2, right? So D is correct. Okay, 10th question. 10th is when the temperature of copper coin is raised by 80 degrees Celsius, its diameter increases by 0.2. Temperature में change किया, diameter change हो गया, copper coin है, whatever. The percent area in the, so percent rise in the area of phase is 0.4, I guess, yeah. Rise in thickness is 0.2 actually, because right, volume 0.6 हो जाएगा, that makes perfect sense. Area of face is 0.4 and volume में 0.6 है, cool. Question of linear expansion of the वो ठीक है, so A and C, I think those are correct. Question of linear expansion, that is, it's like alpha T is what this value is, right? 0.2%, so 0.2 upon 100, that is, so 2 times 10⁻83. And this thing upon the temperature change, that's equal to alpha, which is 80. ये हो जाएगा ये, मतलब 10⁻84 upon 4, which is something like, okay, 0.25 times 10⁻84, 2.5 times 10⁻85, or this thing, both work. So D is right. Next, 11th. For two different gas xy having degree of freedoms f1 and f2, what is this? Natural log of P and molar heat capacity, what at constant volume? C1 C2 respectively. Wait, sorry. Two different gases xy. Chart noise come. xy degrees of freedom f1 and f2 whatever. Molar heat capacities at constant volume as CV. Okay, ठीक है. We know the thing. Okay, and what the natural log P versus natural log curve? Sorry, natural log V curve. Okay, this curve is plotted for adiabatic process as shown. So actually, like e power gamma is constant, right? So natural log of P plus gamma natural log of V is some kind of constant, right? So supposed to be V actually. Natural log of P is equal to negative gamma natural log of V. So the slope is just negative gamma, right? So gamma X is bigger than gamma Y, it seems. And right, what is gamma? It's just the degrees of freedom plus 2 upon degrees of freedom, which is like 1 plus 2 upon degrees of freedom. So that just means 2 upon degree of freedom of x, which is 1. Okay, that's equal to degree of freedom 1. So f1, right? That's bigger than 2 upon f2. So, you know, f1 is less than f2. Yeah, that must be the thing, of course. Right. CV1 is also just less than CV2. Cool. There we go. Okay, करना क्या अपने को? F1 is less than F2. Where is this? Okay, it's B. And CV1 is also less than CV2, which is C. Okay, next question. 12th. Right, gamma X is bigger than gamma Y. And then like CVX is less than CVY. So CV1 is less than CV2, of course. Next, a rigid body of mass M is moving in a circle of radius R with constant speed V. What is the work done by the force in moving the body over half the circumference of this? Sorry, what? Rigid body of mass M moving in a circle of radius R with constant speed V. Mass M, radius R, constant speed V. Okay. What is the work done by the force in moving the body over half the circumference of the circle? Is this a vertical circle or what? Half the circumference of the circle. What is the work done by the force? Which force? Constant speed भी बोला, right? Okay. So changing connection to zero है. Net force ने work zero किया, right? और the force क्या क्या मतलब है? क्या assume करो? कौन सा force? किसके बारे में बोल रहे हो? ये क्वेश्चंस कितने घटिया होते जा रहे हैं. जीरो ऑफ कोर्स, सी इज आंसर. बट ये थर्मोडायनेमिक्स में कैसे आ गया आखिर? आई डोंट नो. नेक्स्ट 13th. Right. Yeah. Okay. 1 mole of an ideal monatomic gas has initial temperature T naught. Okay. It's made to go through the cycle ABCA. ABCA. अच्छा ठीक है. 1 mole of ideal gas. Right. Monatomic gas. ठीक है. N is equal to 1. Monatomic gas reduce of freedom is equal to 3. Temperature T naught. Initially T naught था. फिर क्या हुआ? It's made to go the cycle. If U denotes the internal energy, then choose the correct statement. Oh, come on, seriously, पीवी के पहले चेक करो. इसमें क्या है? इसमें 1 आएगा, इसमें 2 आएगा, इसमें so 2b 2p हो गया, 4 आएगा. So A is smaller than B, smaller than C. What's the big deal, right? Yeah. Come on, seriously. So UA is just equal to like क्या P naught B naught है, which is RT naught because N is 1. UB is 2 आ गया इसमें, it's like 2 RT naught. And UC is 4 RT naught. Cool. करना है आपने को. Oh, wait a second. It's not U that, oh god, अपने को P naught B naught नहीं चाहिए. We want NCV and stuff. So like, okay, 3 upon 2 of all of these guys. So actually supposed to be 3 upon 2. यहाँ पे 3 आएगा. यहाँ पे 6 आएगा, right? Because of course. करना क्या आपको? So what is UC minus UB? That is 3 RT. So B is right. What else? A is correct. Is it? UC is bigger than UB is RT. Can A is correct? Or C is UC minus UA. That's equal to 6 minus 3 upon 2, which is like कितना? 12 minus 3, 9 is just 3. Okay, ठीक है, वो हो जाएगा. 12 minus 3 is 9. 9 upon 2 RT. So Yeah, C is also right. That's also right. Yes, so D is right. Next question, 14th. 14th is, oh sorry, it's, wait, अपन 12 से 18 पे कैसे आ गया अचानक से? 13 14 15 कहाँ पे? हाँ, समथिंग्स नॉट राइट. ये कैसे हो गया? व्हाट, हाउ डिड दैट हैपन? मतलब 12 पे थे और अपन डायरेक्टली यहाँ पे कैसे आ गए? समथिंग्स नॉट करेक्ट अबाउट दिस. दिस इज 18 बट वेयर इज 13? ओह गॉड, ये तो सही नहीं हो रहा है. फाइन, सो व्हाट वी डिड वाज 18. मुझे नहीं पता 13 कहाँ पे डाल दिया इन लोगों ने. हाँ, okay. A sample of pure compound is contained in a liquid, well-insulated container. Sorry, sample of pure compound is contained in a closed, well-insulated container. ठीक है. Heat is added at a constant rate, and the sample temperature is recorded. Okay, the resulting data is sketched below. Which of the following conclusions is justified from the given? Okay, data given. Okay, cool. Sample boils. अबे कहाँ पे? तो करेगा ये तो अपने. ओके, सो पहले क्या है, टेम्परेचर तुम इंक्रीज कर रहे हो, ये जीरो है क्या? और टेम्परेचर कौन से स्केल पर है ये? चल नहीं, ये टाइम है. टेम्परेचर इसका क्या है? जीरो. बट जीरो व्हाट इज दिस, सेल्सियस और व्हाट? भाई टेम्परेचर कौन सी स्केल पर है तो बता मुझे एटलीस्ट. कुछ नहीं दिया तो मैं केल्विन अज्यूम कर लूंगा फिर. व्हाटएवर. तो पहले तुमने इसको इंक्रीज, आई गेस इट्स सॉलिड इन दिस स्टेट. फिर यहाँ पे क्या, इट्स गोना बी लिक, नो इट्स लाइक ओके लेटेंट हीट है ना ये, बिकॉज टेम्परेचर एक्चुअली कांस्टेंट है. सो या ओके, rate of fusion is greater. ठीक है ना, ओपन कर लेंगे. Now it's gonna do this thing. Okay, at 5 minutes the sample was a mixture of solid and liquid. Yeah, actually, right, because यहाँ पे solid था, फिर अब उसके बाद में latent heat है तो फिर वो okay liquid बन रहा है. Yes, so C is correct. और क्या है? At 20 minutes the solid was all liquid. 20 minutes it is no. All liquid थोड़ी बोल, that's not right because ये liquid वाला curve है and then it's going from liquid to gas. और latent heat constant है इतने टाइम में. So yeah, okay, it is not all liquid. Some part of it's gas. So D is wrong. Okay, और क्या है? The sample boils. Of course it does. Right, as you can see. So A is correct. और B correct है क्या? Latent heat of fusion is greater than latent heat of vaporization. So fusion के लिए temperature तुम्हें कितना change करना पड़ा? From this to that. Okay. Wait a second. Wait, something is not. हाँ, जो टाइम है वो दिखाता है कितनी हीट लगी है. सो तुम्हें एक मास को सॉलिड टू लिक्विड ले जाना, राइट. ओके, सो टाइम रिक्वायर्ड कितना है इसमें? इसमें 5 to 10 से थोड़ा सा बड़ा है, राइट. और इसमें काफी बड़ा है एक्चुअली. सो यस, latent heat of fusion is much more than, sorry, rate of vaporization is more than rate of fusion. So B is wrong. Next question, 20. The temperature of an isotropic cubical solid of length L, density T, and coefficient of expansion alpha per degree Kelvin is raised by 10 degrees Celsius. Then at this temperature, a good approximation. Length L, density D, coefficient of expansion alpha. Okay, raised by 10 degrees Celsius, whatever. Yeah, like length is L times 1 plus alpha times 10. So that's cool. A is a good approximation. Total surface area. So cubical solid बोल रहे नहीं? Yeah, of course. So ठीक है ना, मतलब 30 alpha, right, like 1 plus 30 alpha times whatever the initial volume was. Sorry, 30 alpha चलिए, not just 3 alpha. That is the now new volume. So T upon that thing. So D is good. Yeah, density degrees. So D is right. और क्या है? Total surface area is L square times, नहीं. How can that be? Like L square already तुम्हारे पास में कितना, 6L square, right? 6L square था, अब तुम L square ले लो. नहीं, that's just wrong. D should be the thing, right? Isotropic cubical solid. Sure, so D is the thing. और B correct नहीं है. Density is no, ठीक है, C तो पूरा का पूरा correct है. 21. 21 is in the isothermal expansion of an ideal gas, there is no change in temperature. Come on, यार, definition yes ये उसकी. No change in internal energy of the gas. Yes, the work done by the gas. So A, B are correct. Work done by the gas is equal to the heat supplied to the gas. Yes, actually. So C is right. Work done by the gas is equal to the change. Oh, come on, no. Next, 22. ये तो easy था. An ideal gas is taken from state A to state B, right? Along so pressure P, volume P, और इसका P upon 2 volume 2V. So temperature constant along a straight line. What? Straight line path in the PV. I don't get how can that happen? It can't be a straight line graph. That doesn't make any sense. कैसे? अच्छा नहीं हो सकता है, ऐसा नहीं कि नहीं हो सकता है. It's just kind of weird. Select the correct statement from the following. Oh god, that's not looking nice. Okay, ग्राफ करो इसको. P naught V naught is this point. फिर क्या हो गया? P upon 2 and volume का 2 times हो गया. So यहाँ पे and ऐसा. Right? Okay, so that's the work done. Cool. Delta U is just 0, so Q equal to W basically. Work done by the gas in the process. Right, okay, work done by the gas in the process A to B exceeds the work that would be done by it if the system were taken from A to B along an isotherm. Okay, along an isotherm it would be like this. So yes, the work done actually does exceed if the system were taken from A to B along an isotherm. So A is right. और क्या है? In the TV diagram, the path AB becomes part of parabola. Okay, so like PV, right? Okay, so P is just a linear function of volume. So T is equal to a linear function of volume times volume, उससे proportional है. So some kind of square function of volume basically. So yes, it will actually become a parabola. T will be a quadratic in V basically. So yeah, okay, right. Both cases में actual में just ये parabola हो जाएगा, right? Yes. So T is a quadratic in V, and it's also quadratic in P because V is also linear function of P. So in the TT diagram, the path AB becomes the part of parabola. No, that's not right. So B is right. Okay. और क्या है? In going from A to B, the temperature T of the gas first increases to a maximum value and then decreases. So as you can see, यहाँ पे right, it's actually like this. Of course, it's gonna increase and then it's gonna decrease. So that makes sense, sure. Quadratic है ना ये in the end, and quadratic के तो जो zeros है, right? It's like these. So कभी ना बीच में, and of course it's slope negative है, right? So it's a downward, right? कैसे बोलूं मैं इसको? Yeah, it's like this. That's how the parabola should look like. If you just graph T versus V, that's T, this is V, or whatever, right? It should look like this. So 1 point maximum हो जाएगा. Right, so D is correct. Next question. Let's go to 23. Okay. 23. 23 is a wall has 2 layers A and B, each made of different materials. The thickness of both the layers is same. Thermal conductivity of A. K is equal to 3 kb. Okay. Okay. Come on. Temperature of this wall is 20 degrees Celsius. कौन सी wall? A wall. अच्छा ये same wall है, 2 layers की बनी है. Different materials. The thickness of both the layers is same. So A है और फिर B है. Fine. Thermal conductivity of A is Ka, which is 3 times of Kb. Okay. The temperature across the wall is 20 degrees Celsius. Cool. Delta T अपने को पूरा दिया है total. In thermal equilibrium, the temperature difference across A is 15 degrees Celsius. Or the rate of heat transfer. ठीक है, again, no big deal. So like okay, A के लिए क्या है? It's 3 and B के लिए 1 है, right? 3 is to 1 दिया है. So delta T रहेगा, delta T 1 बोल दो. So that's going to be like in the ratio 1 is to 3, right? Because heat flow same हो जाना चाहिए. and then the complete delta T is what? 20 degrees Celsius, like okay, 3/4 of 20 degrees Celsius. That's what this thing is, which is 15, और यहाँ पे 5 रहेगा, right? Okay, those are the temperature gradients, temperature differences, sorry. Okay, in thermal equilibrium, the temperature difference across A, right, across this guy, that's just 5 degrees Celsius, not 15. Rate of heat transfer across A is more, nahi, same hai na yaar, that's the thing. Rate of heat transfer across both is same, so C is the thing, sure. The temperature difference across A is 5, yeah, so D is also right. Next question. 24th. 24th is two metallic spheres AB made of same material have the same surface finish. Mass of sphere A is 4 times. Okay. A, B, mass के बारे में दिया है just 4 times of B, right? A का 4 times है. Both the spheres, so radius कैसा होगा, और क्या same material क्या है ना, या density same हो जाएगी, so radius is in 2 is to 2 power 2/3 is to 1. That's the ratio, of course. Or solid metallic spheres है या hollow spheres, of course solid रहेंगे. Both these spheres are heated to the same temperature. Temperature हमारा same दिया है, whatever, and placed in a room having lower temperature but thermally insulated from each other. Okay, interesting. The ratio of heat loss of A to that of B is, so वो जो T power 4 minus T naught power 4 वाली चीज है वो same है दोनों की. So you just have to look for the area, right? Yeah, proportional to the area. So now जो heat flow है outwards, that's proportional to the area. So like 2 power 4/3 and then 1. Yeah. What do you want? You want the ratio of heat loss upon only the जान चुकी, and what is negative dT upon dt, right? You will also need that in the end. So ये heat flow upon mass with proportional है उससे, so like yeah, 2 power कितना है ये, 2 power 2, so 2 power 4/3 minus 2, which is negative 2, yeah, like 4/3 minus 2 is just negative 2/3, of course, like 1 is to 2 power 2/3. That should be doing it. Okay, that is the thing, like it's just 4 power 2/3, isn't it? Yeah, that's why. Okay, तो करना क्या अपने को? Oh wait, अच्छा अपने को इस, right, just let it be 2 power negative 2/3 in that case. Is to 1. Cool. So ratio of heat loss of A is to B is 2 power 4/3 heat loss. This is the thing. Yes, that's right. So A is correct. The ratio of initial rate of cooling of A to that of B, that is 2 power negative 2/3. Yes, actually. So C is also right. Next question, 25th. A body of mass m is attached to the lower end of a of a metal wire whose upper end is fixed. The elongation of the wire is L. Loss in gravitational potential energy of capital M. अजीब है ये थर्मल इसमें कैसे आ गया आखिर? So capital M है ये body. So it's a metal wire. Okay, lower end. Whose upper end is fixed. The elongation of the wire is L. Right. The loss in gravitational potential energy of M, that is mgl, understandable. The elastic potential energy stored in the wire is mgl. No, the thing is it's like half kx square, right? So half kl square in this case, and we know that kl, that's just equal to mg. So actually this is like k is equal to mg upon m. You can just say it's like half of mg times l, basically, right? So yeah, 1/2 mgl, that's the elastic potential energy stored in the wire. The heat produced is 1/2 mgl. That makes sense, sure, because energy conservation, sure. So like that should be the thing. Yeah, that's the thing. Wait, iska mass assume karo 0 hai. Yeah, so D is right. Heat produced is half mgl, makes sense. And the elastic potential energy stored in the wire is 1/2 mgl. So C is correct, D is correct, and A is correct. But actually we know that in reality ऐसा नहीं होगा. जब तुम इसको छोड़ोगे then there will be kinetic energy when it reaches this position, right? Yeah, because equilibrium position पे जाने पे वो like SHM करता है. We know it's gonna be an SHM. तो अपन अज्यूम कर रहे हैं कि वहां पे जीरो हो जाएगी वेलोसिटी. इन रियलिटी दैट्स नॉट गोइंग टू हैपन, बट व्हाटएवर. हाँ, तो तुम इसको डैम्प कर सकते हो यूजिंग फ्रिक्शन, फ्लूइड फ्रिक्शन. एंड देन तुम बोल सकते हो कि कुछ टाइम के बाद में वो या मोशन उसकी रुक जाएगी. देन इट्स करेक्ट. नेक्स्ट. कितने हैं इसमें? थोड़े और हैं. ओह कम ऑन, ये क्या हो रहा है इसमें? ओके, लेट्स गो टू व्हाट 2627 क्या? Okay, the figure shows the radiation energy spectrum for a spectrum graph for a black body at a temperature T. Okay, at a temperature T. So lambda दिया and then like okay d e lambda upon t lambda. तो d lambda की रेंज में तुम्हारी कितनी एनर्जी है, राइट? फ्रॉम या उसका कंट्रीब्यूशन कितना है एनर्जी में. ओके, दैट मेक्स सेंस. ऑफ कोर्स. सो 26 करते हैं. The radiation energy is not equally distributed among all possible wavelengths. Duh, obviously. So A is right. For a particular wavelength, the spectral intensity is maximum. What? Particular wavelength, the spectral intensity is maximum. Yes, actually. So B is right, which is of course this lambda m. The area under the curve is equal to the total rate at which heat is radiated by the body at the temperature. Of course, C is also correct. Next, 27. If the temperature, and we want the correct statements. So, if the temperature of the body is raised to higher temperature T, then choose the correct statement. The intensity of the radiation for every wavelength increases. So, for every wavelength. I mean, I think that should be the case. तुम्हारा बस तुम शिफ्ट कर रहे हो इसको एंड देन इट्स लाइक जो एरिया है चेंज. आई गेस या इट शुड इंक्रीज, राइट? इट्स काइंड ऑफ अ वियर्ड क्वेश्चन बिकॉज़ मैंने इस तरह कभी सोचा नहीं है क्या ये एक्चुअली में हमेशा इंक्रीज होगा. और अब मुझे इसका डिस्ट्रीब्यूशन एक बार देखना पड़ेगा. सर्च करके मैंने पे मैक्सिमम इंटेंसिटी ऑफर्स एट द शॉर्टर वेवलेंथ. हाँ, तुमने टेम्परेचर को इंक्रीज किया सो लैम्डा मैक्स छोटा हो जाएगा, लैम्डा एम छोटा हो जाएगा. नॉट मैक्सिमम लैम्डा, इट्स लैम्डा एट विच यू हैव मैक्सिमम इंटेंसिटी. सो यस, बी इज राइट. ओके, सो एट लीस्ट बी इज राइट. ए का मुझे पता नहीं. द एरिया अंडर द ग्राफ इंक्रीजेस. श्योर इट डज. The area under the graph is proportional to the fourth power of temperature. Yes, it is. Right. Intensity of radiation for every wavelength increases. That's, I don't know. I really don't know. Yeah. Whatever. Next. पर ऐसा होना नहीं चाहिए कि एक्चुअली सब इंक्रीज हो ही जाएगा इंडिया कि कुछ ऐसे रहेगा जो कि तुम्हें डिक्रीज हो गए. आई डोंट नो. 28. An ideal gas has molar heat capacity at constant pressure. Cp is equal to 5 R upon 2. Okay, the gas is kept in cylindrical vessel fitted with piston which is free to move. So लिखो फटाफट. Cp is 5 R upon 2. Wow. Cv is 3 R upon 2. You know the usual ideal gas. The gas is kept in a cylindrical vessel, okay, fitted with a piston which is free to move. Draw करते इसको. Piston which is free to move. Cool. Side walls of the container and the piston are non-conducting, so it's adiabatic. Cool. Mass of the friction, so it's like adiabatic. If you don't know. Mass of the piston is 9 kg. Okay. Initial volume of gas, so V naught is T is many meter. You know, so 27 times 10 power what? 1, 2, 3, 10.84. Okay. And the cross section area of the piston, so that is okay, 9 times 10.82. The initial temperature of the gas, so T naught is 300 kelvins. Atmospheric pressure P naught फर्क नहीं पड़ता अपने. And amount, this much of heat energy is supplied to the gas by heating coil, so Q is equal to कितना? 2.5, 25 times 10 power C basically, right? By heating coil, then initial pressure of the gas अपन ढूंढ सकते हैं which is what? Okay, so it's volume दिया है, temperature दिया है, moles दिए क्या अपने को नहीं दिए. But initially equilibrium में था क्या? Initial equilibrium में था कि नहीं था ये? अज्यूम करो इक्विलिब्रियम पे था. इन दैट केस हाँ अज्यूम करो क्वासी स्टैटिक प्रोसेस है, इक्विलिब्रियम में था हमेशा थ्रू आउट. या जस्ट डू द थिंग, क्योंकि अपने को पीवी पोलैरिटी लगाना है राइट. सो उसके लिए अपने को अजम्पशन लगेगा राइट. इन दैट केस ठीक है ना, प्रेशर अपन आराम से निकाल सकते हैं. जस्ट एम जी थिंग अपॉन द एरिया व्हिच इज 9 टाइम्स 10. जी को क्या अज्यूम करना है अपने को? ओ गॉड, अपने को दिया नहीं है. That's not, अच्छा एटमॉस्फेयर प्रेशर अपने को दिया हुआ राइट. सो नॉट जस्ट एम बट यू आल्सो वांट दैट पी नॉट वैल्यू. दिस इज बैड. So 9 times 9.8 approximately upon area is just this guy. So 9 times 10 power negative 2. So yeah, it's just like 9.8 times 10 power 2. Like okay, 980. These many pascals. And then और क्या अपने से 1.05 something times 10 power. इसको 10 power 5 में convert करो यार. So 0. इसको approximately 100 ही ले लेते क्या जा रहा है right? Of course. So इसको 10 power 5 में convert करूँगा. So like 10 power negative 3 basically. It's like 0.001 times 10 power 5 pascals. And originally कितना 1.05 है. So that with this, okay, it doesn't even match. It doesn't even match. Wow. That's not good. 10 power 3 था. It should be... Wait, something going wrong, of course. It's not that. It's 10 power 2. So 10 power 3, and that's like 10 power negative 2, not negative 3. It should be this thing. तो अब ये मैच करेगा because yeah, it will be 1.06 times 10 power 5 approximately. Yes, that's the thing actually. So A is correct. और क्या है? Final temperature of the gas is something whatever. तुमने heat बताई है, ठीक है ना, no big deal. Initial temperature भी दे दिया है, so right. Q upon or pressure constant है, I guess. So you gave us Cp, perfect. Heat upon Cp कर डालो. So 25 times 10 power 3 upon, and they didn't give us R unfortunately. ठीक है ना, R अपने को याद रखना पड़ेगा. 5 upon 2 times R कितना है? Yeah, R is like 8.3 in SI units. So come on, seriously. तो ये क्या हो जाएगा? 5 ऊपर 10, so like 10 power 4 upon 8.3. Yeah, that's our delta T, isn't it? And this is what मुझे करना क्या था वैसे राइट. इतना इंक्रीज होगा. फाइनल टेम्परेचर ढूंढने के लिए इनिशियल टेम्परेचर लाइक 300 प्लस दिस गाय. सो 300 प्लस 10 पावर 4 अपॉन 8.3 इज लाइक 10 पावर 5 अपॉन 83 which is 100 upon 83 times 10 power 3. That's actually a big number. Yeah, right. So टेम्परेचर तुम्हें कहाँ पे? It's like 1000 kelvins, huh? Interesting. Something's not right about this. कुछ तो भी गड़बड़ हो रही है इसमें. Yeah, टेम्परेचर नीचे भी दिया था and then 25 times 10 power 3, sure. Something's not right. ये चीज और ये चीज ये मैच कर रहे हैं इस तरह से? I don't think so. Clearly it's not like 700. How is this equal to 700? Is this equal to 700? 10 power 5 upon 83 is equal to 700? It's like saying is 10 power 3 is equal to 7 times 83. It's like saying is this equal to, yeah, 1, 2 carried on, you got 56, okay, like 5, 7. No, it's not even matching that. आधा है उसका सिर्फ. So B is wrong. Final pressure of the gas is हाँ same रहेगा, no biggie. Work done, so C is actually right. B is not right. C is right. Work done by the gas is 9.94 times 10 power 3 by the gas. Oh. Uh-oh. There's not just heat, there's also the work. I don't like this thing. Okay, मुझे समझा क्या गलत हुआ अपना. Wait, but this was right. Actually, like heat upon Cp, that should give you the delta T thing, right? So heat upon NCP, that should give this thing. और N कितना है? Ideal gas molar heat capacity. कितने मोल्स है मुझे तो बताओ एटलीस्ट. वो अपने को ढूंढना पड़ेगा. Oh God. You don't even know the moles. I don't like this thing. तुम्हें इनिशियल टेम्परेचर दिया है, तुम्हें वॉल्यूम दी है, प्रेशर तुम्हें पता है, राइट. सो प्रेशर अपन ने कितना 1.06 times 10 power almost 10 power 5, right? 10 power 5 is like, okay, p naught times v naught is just this guy, 27 times 10 power कितना -4 upon rt, right? Not nice, not nice at all. Yeah, okay, 5 upon 2 nrt होगा यहाँ पे, right? Okay, so nr, and then you got this heat. That's what you look for. But then what is nr? It's just pv upon, right, p naught v naught upon t naught. तो वो चीज यहाँ पे put कर दो, it's like 2q upon 5 p naught v naught, and then this whole stuff times t naught. That is our delta t, right? So actual में t naught times 1 plus 2q upon 5 p naught v naught, that is what we should be looking for. So like 300, ठीक है ना, वो तो बाद में कर लेंगे, पहले ये चीज ढूंढ लो. So 2 times कितना q था रे? 25 times 10 power 3 upon 5 times p naught. What is p naught? Almost 10 power 5. That is v naught. What is v naught? अपन ने अभी निकाला था 27 times 10 power negative 4. It's just taking forever, isn't it? It's like 10 power 4 आ जाएगा यहाँ पे. ये क्या है? Just 10 power 1, 10 power negative 3. ऊपर भेज दो इसको 10 power 3 upon 27, right? Okay. And then this thing times 300, like, yeah, 300 plus this guy, right? And you want in kelvins, I guess, right? So this times 3, this is right, of course. What could go wrong? This times 300, मतलब कितना? 3 times 10 power 5 upon 20, well, basically 10 power 5 upon 9. I'm actually doing it. So अच्छा, वो जो 1.06 वगैरह था, oh, that was to make this slightly bigger. हाँ, interesting. So 100 तुम बाहर निकाल लो, just 3 plus 1000 upon 9. No, that doesn't make any sense. How can that be the thing? No, that's not right. Something must have gone wrong. It's taking forever. Q had this thing, so 10 power 3. It's 10 power 4 over there, sure. And what other thing? P naught. P naught is just 10 power -5. That was like 5 as well. That answered 5 यहाँ पे आ गया. It's 10 power 3 हो गया. And then you got 10 power 5 is there, sure. Anyone else thinking it's just taking forever? 10.83 होना चाहिए ऊपर, तो 10.3 गया. 127, right? नहीं, कुछ तो गड़बड़ है इसमें. Just do this once again. T naught is just 300. 1 plus 2 times Q. Q is 25 times 10 power 3. Right? Yeah. Upon 5 P naught. Right, it's at not approximately 10 power 5, right? Because अपन ने जो निकाला, it's, yeah. Okay, and that times V naught. So volume is this thing, 27 times 10 power 4. Right? अबे -4 होगा ना, sorry. -4. Right. That's the thing. That's what we did, of course. So इसको कैलकुलेट करना पड़ेगा, जिसमें 10 power 1 in that case, और ये हो जाएगा यहाँ पे 5, you got 10, 10 power 4, and then just 10 power 1, like 10 power 3, 10 power 3 upon 27, and then this thing times 300. So yeah, 3 times 10 power 5 upon, like, ये चीज, and yeah, 10 power 5 upon 300. How does that even compare to hundreds or what? No, it's not 1000 Kelvin in any case. Because ये क्या होगा? It's like 1000 upon 9 times 100. So वो किसी भी एंगल से 700 तो नहीं हो रहा है. Doesn't make sense. Okay. Right. Okay. Work done by the gas. Yeah, the pressure is constant, like P naught V naught. Actually, P naught delta V, whatever. Right. मैं क्या कर रहा हूँ आखिर? Work done by the gas. So heat provided is just, NCP delta T. Okay. And the internal energy का जो change है, that's equal to NCV delta T. मैं क्या कर रहा हूँ? Should I even be doing this thing? No. Delta T अपने को पता है नहीं, अपन वो नहीं यूज कर सकते. Just have to use P naught V naught stuff. फाइनल टेम्परेचर क्या है एग्जैक्टली exactly? हाँ आपने को हीट दी है राइट ओके या सो व्हाट वी हैव इज and we want the work done which is delta p v r right so just nr delta t that's what we look for तो उसके लिए just have to look for it's like 5.2 so for 2/5 of q that is our work done actually because q is 5/2 nr delta t right yeah or nr delta t is actually equal to delta p naught v naught and actually p delta v naught whatever that's the work done that's the work done actually so 2/5 of this guy which is 2 times 5 times 10 power 3 matlab ki 10 power 4 right that's the work done 10 power 4 joules approximately yeah d looks correct next question काफी टाइम लग गया ये करने में next 29 29 is considered the shown case of freezing lake due to negative environmental temperature. Okay. Thickness of ice layer is small in comparison to depth of lake. Rate of increase of sorry in x will be greater if okay ठीक है so right thickness of ice layer is small in comparison to depth cool increase in x right so it's increase what fine and the water is at what temperature we don't know oh no it actually is like yeah okay अंदर का temperature थोड़ा अलग रहता है right the warmer water comes down and then the colder stuff remains on the top basically yeah you can say so okay if environmental temperature increases yes that's for sure wait no not increases it should be decreases right then yeah for larger thickness of ice layer मतलब कि तुम्हारा डेल्टा टी और छोटा हो जाएगा इन दैट केस बिकॉज not make sense it's inverse proportional to L right so no जितनी thin layer है उतना better रहेगा right for smaller thickness of ice layer so yeah rate of increase of x so D is right and A is right A and B I guess that should do it fine let's check nah whatever that's it integer type है but 8 questions right I'll see you guys in the next video because अपने को ये भी करना पड़ेगा script type and everything oh इसमें भी कम questions actually में ठीक है ना अगले वीडियो में कर ही डालूंगा so that's it I'll see you guys in the next video bye